Water spotting and etching are often dismissed as customer abuse or environmental exposure, but in OEM durability engineering, they are treated as a controlled chemical attack on the Clearcoat surface. These defects are not random. They occur when the chemistry of water deposits, surface temperature, and Clearcoat resistance intersect in an unfavorable way. Water spots are not caused by pure water. They are caused by dissolved minerals, salts, and contaminants left behind after evaporation. Calcium, magnesium, sodium, silica, and airborne industrial fallout are the real aggressors. When water evaporates on a hot surface, these contaminants concentrate into a highly alkaline or acidic residue. At elevated surface temperatures, chemical reaction rates increase dramatically, turning a simple water droplet into a localized etching solution. The distinction between water spotting and etching is critical. Water spots are deposits sitting on top of the Clearcoat surface. Etching occurs when the chemical residue reacts with and penetrates the Clearcoat, permanently altering the polymer network. Spotting can often be removed. Etching cannot, because material has been chemically damaged or dissolved. Surface temperature is the most underestimated factor. A panel exposed to sunlight can easily exceed 70 to 80 degrees Celsius, even when ambient air temperature is moderate. At these temperatures, the Clearcoat softens slightly, diffusion increases, and aggressive ions penetrate more easily. This is why water spotting is most severe on horizontal surfaces like hoods and roofs. Clearcoat chemistry defines resistance. High crosslink density improves chemical resistance, but increases brittleness. Lower crosslink density improves flexibility, but increases permeability. OEM Clearcoats are balanced to survive both chemical attack and mechanical stress. Small formulation changes that improve gloss or flow can unintentionally reduce water spot resistance. Additives influence surface behavior, but cannot fully protect against etching. Slip and flow additives reduce water retention by lowering surface energy, encouraging droplets to roll off rather than sit and evaporate. However, excessive use can reduce detergent resistance and increase micromarring. UV absorbers and hulls protect against photodegradation, but do not prevent mineral attack. Curing plays a decisive role. Undercured Clearcoats retain residual solvent and unreacted functional groups, increasing water uptake and chemical susceptibility. Overcured Clearcoats may resist chemicals initially, but develop microcracks during thermal cycling, which later become attack sites. OEM bake windows are designed to optimize chemical resistance without sacrificing durability. Water quality in the plant matters more than many realize. Deionized rinse water is standard for a reason. High conductivity water used in final rinses or leak testing can deposit salts that initiate early etching, sometimes before the vehicle even leaves the plant. These early-stage defects often appear weeks later, creating confusion during warranty investigations. Environmental exposure defines real-world performance. Acid rain, bird droppings, tree sap, and industrial fallout all interact with water spotting mechanisms. Bird droppings are particularly aggressive because they combine acidity, enzymes, and moisture retention. Clearcoats that survive mineral spotting may still fail under organic contamination if chemical resistance is insufficient. Testing methods include water spot resistance tests, artificial rain simulations, and bake and condense cycles. OEMs correlate lab results with field exposure in hot, humid climates. A Clearcoat that passes room temperature lab tests, but fails in tropical regions, usually lacks high-temperature chemical resistance. From a troubleshooting standpoint, when water spot complaints arise, engineers first determine whether the defect is removable or etched. Microscopic surface analysis, solvent rubs, and polish trials distinguish deposit from damage. Formulation changes are considered only after curing, bake profiles, and water quality are verified. Water spotting is not a customer care issue alone. It is a chemical durability performance metric. When Clearcoats are designed and processed correctly, water may leave marks, but it should never leave permanent damage. If you have questions about water spotting, Clearcoat chemistry, or why some vehicles etch faster than others, leave them in the comments. We'll continue breaking down durability-driven defects with OEM-level clarity in upcoming episodes.